Hi everyone, we're going to be learning how to graph linear equations using a table today. So let's begin your essential question for this set of notes. What form should the equation be in before you set up your table? So we're going to go through a little refresher here first. So I just want to refresh you guys your brains on how to actually put these equations in y equals mx plus b form, or just to solve for y. So we can see that y is on the left side of my equation over here, so I need to get rid of anything else that is with that y. That's a positive 2, so in order for me to get rid of that positive 2, I'm going to subtract 2 from both sides of my equation. So this means that negative 2 and a positive 2 cancel each other out, and we have y equals, you always want to, we're putting this in y equals mx plus b form. We're trying to get that y by itself. So that means we want our x values next. So my x value was this 4x, so I have a 4x here, and then I have my negative 2. There we go. We just got y by itself, so I have y equals 4x minus 2. Now our next one, we need to still get y by itself. Y is being multiplied by that negative number. There's a negative 1 in front of that. So in order to get rid of being multiplied by a negative 1, we need to divide by a negative 1. And you guys are welcome to either just divide the whole thing on that right side by negative 1, or I just like, this is the same thing actually, because that negative sign, sorry, let me back up here just to show you another way. So negative 1, and then you can also do it like this, where you just know that you're making sure that that negative 1 goes to all the values. So a negative divided by a negative is now a positive, and then a positive divided by a negative is a negative, and 5 divided by 1 is just 5. So we have our 5x, and then we have a negative 7 divided by a negative 1. A negative by a negative is a positive. 7 divided by 1 is 7. And this is our y equals negative 5x plus 7. Now, we have our last two problems for this, just refreshing our memory again. So we want to get rid of our x first. We're trying to get the y by itself. I see that's on the left side of my equation where that positive 4x is. So I need to subtract 4x from both sides. Go ahead and put your equal sign. These cancel each other out because one was positive, one's negative. And now I have a 2y left over here. I'm not allowed to combine these two because this 8 does not have an x, but that 4 does. So I can't combine those. Those are not like terms. So I now have a negative 4x plus 8. And then I need to get rid of that 2y. So that's 2 is being multiplied by y. So let's go ahead and divide everything by 2 so that we make sure that we can divide that out, and that equals 1. 1 times y is just y. So now I have y equals negative 4 divided by 2. Let's just do our negative divided by positive first, which is a negative. 4 divided by 2 is now 2. We had a higher number on the top of our fraction, which means we're going to get that whole number. And then again, we have a higher number of this 8, and being divided by 2 again, which is now 4. Yay, our y is by itself, so now we have our y equals negative 2x plus 4. All right, our last one over here. So again, my 3y negative 6, that's all on the left side, so I'm going to go ahead and get rid of that positive or that negative 6 by adding 6 to both sides. Now, again, those cancel. 6 negatives plus 6 positives cancel each other out. We get 3y equals, my x's go first, and I cannot combine it with that 6 because that 6 did not have any x's. Now, that y is being multiplied by a 3, so we need to divide by a 3 and everything so that we make sure that we get the y by itself. So go ahead and do y equals, those divide out again. 9, 3 goes into 9 3 times, so we still have the x with it, and then 3 goes into 6 2 times. So again, you can cross those out. This has a 2 here, cross these out, this has a 3 here. Okay, so we're left with y equals 3x plus 2. Now, how to actually use a table to graph. This is just going to be your part 1 first. So get the y by itself in the equation, just like we just did on our 4 previous examples. You're going to make a table of values using the domain, and I want you to use these in your table every single time of negative 1, 0, and 1. Our last step, you're going to make sure you plot those points on your graph and connect the points, creating a straight line. So let's go ahead and do our first example. Our first step was getting our equation into y equals mx plus b form. We see that our y is not alone. We have that positive 1 over there, making it not by itself. So in order to get rid of that positive 1, I need to subtract 1 from both sides, and now I get y equals, make sure that you have, let's actually write y equals mx plus b just so you guys know what comes next. So now I have my x values, so negative 2x, and then you have your constant of minus 1. That's your b value. So what we just did, we got our y equals negative 2x minus 1. We just did our first step. We put it in y equals mx plus b form. Now we are going to write that value, that negative 2x minus 1 in this little table here. So go ahead, make sure that you have your negative 1, 0, and 1 in your x. That's your domain, x values. And then we want to go ahead, we just solved for this equation right here, negative 2x minus 1, and we just brought it all the way over here because this is what we're going to be doing our math with. Okay, so let's go ahead and plug in. So the first value we're plugging in for x is this negative 1. So we're going to go ahead and do negative 2, but this time instead of putting x, we're actually multiplying it by that negative 1 in our domain right there. And then once we multiply those, then we're going to subtract 1. So you have to do this portion first. Negative 2 times negative 1 is a positive 2. And what's 2 minus 1 now? We get a positive 1. So now we have our x value and our y value. So we're going to go ahead and actually make this as a point. Remember your x values, what we just got from here, are negative 1, and our y value that we just solved, which is 1 right here. So negative 1, comma 1 is going to be our first point on our graph. So let's actually graph that at the same time. I know we're doing kind of two steps at once, but if I do negative 1, comma 1, we're going to have a point right there. All right, let's keep doing our math. So our next value that we get is 0. So we're going to rewrite that negative 2, but this time we are going to multiply it by 0. And then once we do that, so negative 2 times 0 is 0. Don't forget subtracting that 1 at the end. So negative 2 times 0 is 0, but then 0 minus 1 is going to be a negative 1. So let's go ahead and write this point now. So our x value was a 0. That's the value we plugged in for our equation. And then when we plugged it in, we got a little, it like went through a little robot, and all of a sudden it came out a negative 1. So that's our little function operation. So let's actually do 0, negative 1 on our graph, which is right here. And then we're going to go ahead and do our last point here. So now we're plugging in the value of 1. So into our equation for x, negative 2 times our 1 value, and we're going to subtract 1 at the end. So negative 2 times 1 is negative 2, and then negative 2 plus one more negative is actually going to be a negative 3. So our new point is our x value of 1, and then we just plugged in 1 to our equation right here, and we see that it spit out negative 3 once I actually went through and did my actual work. So let's go ahead and plot that point. So go to the right one, and we're going to go down 1, 2, 3. So these are my 3 points, and my last step on this was to connect my dots to actually see if it formed my line. Yay, it actually did, so that means that I did my math correct, and I did end up getting my linear equation. Alright, let's do another example of this, and then we will, I have 2 more examples so I can really get this into your guys' heads. So go ahead and solve y equals mx plus b again. We are going to subtract this 3x first, subtract 3x first, and then we are left with a y equals negative 3x plus 2. So this equation here goes all the way up here so we know what we're doing our work with. So negative 3x, and then we have a plus 2. So now we are going to go ahead and take that x value that we were given, our domain, our negative 1, 0, 1. We have to plug those numbers in. So I want negative 3 times our negative 1. And then we're going to add 2 after all we've multiplied. So go ahead and do negative 3 times negative 1. Negative times a negative is a positive. And then 3 times 1 is 3. And we're going to add 2 more to that. So we get a 5. So let's go ahead and write our new point. We have negative 1 that we plugged in, and we got out a 5. Now let's do our next point. 0. We're plugging in the 0 into our x equation. So negative 3 times 0. If you want to do it color coordinated, you totally can. It could be green. And then we have our plus 2. So negative 3 times 0 is 0, but then we're going to add 2, so we get 2. Let's go ahead and write that point down, 0, comma 2. And you guys can totally be graphing these as you go along, but I'm just doing all of this at once. And then our last point we have to test out, plug that 1 in for the x into our negative 3 times x, but instead of x we are plugging in the 1, and then we're going to add 2 at the end. So don't forget this whole part. Negative 3 times 1 is a negative 3. Negative 3 plus 2 is a negative 1. So now my new point is 1 comma negative 1. Okay, so now I'm going to go ahead and actually plot all three of those points. So for that negative 1, 5 value, we're going to go to the left one, up 1, 2, 3, 4, 5. And then we have our second value, that 0, comma 2. So we're going to go 0, nowhere left and right, but up 2. And then we have our 1, negative 1. To the right, down 1. All right, awesome. It looks like we actually did this right again. We were able to create another line, so therefore we have a linear graph. Okay, let's do one more example of this. So our first step, we're going to be solving y, getting it by itself. It actually is not by itself, it has that negative 1 being multiplied by it. So we're going to go ahead and divide by a negative 1. And then we see that we have a y equals negative divided by negative is a positive. And then a positive 3 divided by a negative 1 is actually a negative 3. So our equation here is y equals x minus 3. So you can either write this whole thing and put it here. I just don't have room, you guys, so that's why I've only been taking this section just so I can see that's the math I'm doing. But that is where your y's come out. So that's why, let me just show you over here. So if I were to do y equals, and I plug in that negative 1 for your x, and then subtract 3. So negative 1 minus 3 is actually a negative 4. Negative 1 minus 3 more is negative 4. So see how it says y equals negative 4? That's why I've been writing it in this box as my y. So that negative 1, I'm just going to show that I always put whatever I plug in parentheses so I know that I've already done the work and included that value. So awesome, I got my first point, negative 1, comma, and then the negative 4 came out once I did my actual math. Now I'm going to do 0, plugging in 0 into my equation here. 0 is just 0, so minus 3 is going to be a negative 3. That means my new point is 0, comma, negative 3. Again, take your x and your y values. And then we're going to now do 1 minus 3. So 1 minus 3, if you have $1, you're going to subtract $3. Someone takes $3 away from you, you actually had $2 left over. So 1, comma, negative 2. And then we're going to go ahead and plot those points. Negative 1, 1, 2, 3, 4. And then we have 0, comma, 3, negative 3, sorry. And then 1, comma, negative 2. Yay, we created a line again. Beautiful, beautiful, beautiful on our graphs. Now let's go to part 2. So, how to use a table to graph part 2. You're going to get the y by itself in the equation still, and then make a table of values using strategic numbers you choose. So this time you're going to be choosing your values instead of always doing negative 1, 0, and 1. Then you're going to plot the points on the graph and connect the points to create a straight line. So for our example, we only have 2 examples for this one. So we need to put it in our y equals mx plus b form. So always, always, always y equals mx plus b. I see that my y is by itself, but it has this stuff over here. Sorry, this stuff right here. So we will need to get rid of it. Well, it is a 1/2 x. So we're going to add 1/2 x. It's okay if it's a fraction, you guys, you can handle it. Add 1/2 x to both sides, and now we're left with y equals, our x always comes first, 1/2, and we don't get to add it to that 1 because that doesn't have an x. So our equation that we get to put right here is 1/2 x plus 1. So what I mean by strategic x values, if you guys are ever given a fraction, you always want to use numbers that are multiples of that. So 2, 4, 6, 8, and so on. However, I only give you 3 numbers. 0 is always a nice one. So what I'm going to do is we can either do positives or we could do negatives. It's up to you guys. So let's just try 0, 2, and 4. Okay, so let's go ahead and plug in 0 into our equation first. So 1/2 times, let's do this in a different color so you guys can see where I'm plugging it in, and then we have plus 1. So anything times 0 is going to be 0, plus that 1, we get 1. So our point is 0, 1. Not too bad dealing with fractions, right? Okay, so then now we have our 1/2, and it's going to be multiplied by the 2 and added 1 at the end. So whenever we have a fraction, let me show you this. This 2, this is being multiplied. This 2 becomes a fraction like this. Well, look at 1 times 2 is 2, 2 times 1 is 2, and 2 divided by 2 is just 1. So this 1/2 times 2 right here, that's like the only thing that we see, is really actually just 1. If you need to rewatch that in the video, you guys please rewind it, slow it down, and rewatch it. So 1/2 times 2, this portion right here, is actually only 1, and 1 plus 1 is 2. So our next point is 2, 2. So this is why I'm picking these multiples, because it's making my fraction actually turn out very nice. So let's try our 1/2 times our 4 now, plus 1. Well, let's trade this out and actually put a 4 here instead. Let's see what happens. So this is really 4 over 1. See, I can even just put my fraction right there. You multiply fractions straight across. So 4 times 1 is 4. Let's erase this so we can see it. 4 times 1 is 4, and then that 2 times 1 still stays as 2. 4 divided by 2 is 2. So that's my new value there. So our points are coming out nice if you pick strategic x values to make your life a lot easier. So now our last step, you guys, is to go ahead and plot that point, those 3 points, so 0, 1, 2, 2, and then 4, 2. 1, 2, 3, 4. And how did we get a 2? Hang on. Nope, I just caught my own mistake. So let's try that again. 4 divided by 2 is 2, but I forgot to add that 1 right there, so this is actually a 3. And see how if I were to graph that, you guys, this would be 4, 2. See how that would not create a line? So that's why I just realized I had a mistake. So this is actually 4, 3. So now I do have a line because my point value 1, 2, 3, 4 is up here. And now I do have a line that I can create. Okay, and then our last example, you guys, we're just going to do one more so you guys can be professionals at this and go on and do your own worksheet. So we have to get y by itself, divide by 3 on everything. So now I get y equals, and this is just a little invisible 1. If you guys like seeing what fraction you have, you can totally do it. If not, just leave your x like that. And then negative 6 divided by 3 is a negative 2. So now I have 1/3 x minus 2. Oh, look, we have a fraction. So we're going to pick our strategic x values. I always want 0 because I know anything times 0 is 0. So like on this one, 1/3 times 0. Oh, look at 1/3 times 0 gets rid of that fraction, and we're going to subtract 2. So we're left with a negative 2. So my point that I'll be graphing is 0, negative 2. Then I need to pick strategic x values. So what are multiples of 3? Well, we know 3 actually is with 3, as well as 6. So let's see what we got here. So if we do our 3 that we plug in, 1/3, and now we're going to plug in the 3 instead, and then subtract 2 at the end. So just make this a fraction. 3 times 1 is 3, and 3 divided by 3 is 1. 1 minus 2 is a negative 1. So my new point's 3, negative 1. If I did that fast again, go ahead and listen to me, rewind it. And then 1/6 times, 1/3 times 6. Remember, just make that a fraction over 1, and we're going to subtract 2. So 6 times 1 is 6, divided by 3, because I just did 3 times 1, and now I get 2. Well, 2 minus 2 is actually 0. So my last point is 6, 0. So I'm going to go ahead and graph these last 2 points that I did not graph on my graph. So 3, negative 1. And then we also had 6, 1, 2, 3, 4, 5, 6. I'm going to be a little off my graph. 6, 0 is right there. Go ahead and connect those dots, and you do get a line again. All right, you guys. So just to recap what you guys actually did, we did a lot. We refreshed our memory on solving for just an equation in y equals mx plus b form. We also went through and I gave you a set domain of negative 1, 0, and 1, but you guys were still just plugging it into your table and solving for those values. Once you guys did that, you plotted your points and you created a graph. And then you guys even came up with your own x values to come up through that. to come up with your own table and graph. So great job, you guys. Think about your essential question again, because you guys will be answering that in the future. So what form should the equation be in before you set up your table? Thanks again, you guys. I will see you next time.